In the modules up to this one, we focused on using game theory and using math and some analysis to talk about firm pricing, mergers, collusion, all these sorts of things. Oftentimes, for simplicity, when we were doing those models, we would assume that the decision makers had perfect information, that they knew what was going on. Even when they didn't know what their opposition was doing, like in game theory, they knew what options they had and they had an estimate of what their payoff would be for the different outcomes, and then they were basing decisions on that. In this module, we want to introduce the idea that maybe either because of risk or uncertainty, when making decisions, whether it's through a rule, through game theory based on experience, the decision makers may not have perfect information in terms of what's going on. Now, at the outset, we need to make a distinction between risk and uncertainty. Oftentimes, decision makers confuse these two things. So, risk is a decision making situation where there's different outcomes, and the probabilities of those outcomes can be measured in some way. So, I know that if I play the lottery, there's such and such a chance of actually winning. I know that if I get in my car, there's such and such a chance of getting into an accident, something like that. So, risk, there's some known probability. It doesn't mean that you know which end of that probability you're going to get. I mean, you wouldn't get in your car if you assumed you were going to get in an accident, but you know there's some risk or some possibility of that happening. Uncertainty, on the other hand, is a decision-making situation where there's different possible outcomes, so that part's the same, but the probabilities of these outcomes cannot be measured, sometimes because all possible outcomes cannot be foreseen or specified. It is very common for decision makers to chalk up risk to uncertainty, to think you can't estimate, you can't try and figure out, you can't measure the risk, and so you chalk it up to uncertainty. But there are situations where there is uncertainty, but not nearly as much as people want to attribute to uncertainty. Sometimes it's just lack of creativity or effort in terms of calculating out the risk. Now, the easiest rule for making a decision with risk is just to calculate the expected value, which is the sum of the products of the values of different outcomes multiplied by their respective probabilities. So, for example, here's two options, option A and option B. So the expected value of option A is 0.75 times 100 plus 0.25 times 0. So the expected value here is $75. Over here for option B, the expected value is 0.02 times 500 plus 0.65 times 100 plus 0.33 times 0, which is also equal to $75. Now, I set this one up specifically so that both sides are equal, so that we can then start thinking about and talking about how people actually think about risk. Just because these two are equal doesn't necessarily mean you should be indifferent between them. So option A has an expected value of 75. There's a 75% chance you get 100, a 25% chance you get 0. Option B also has an expected value of 75, but the different outcomes and their associated probabilities are very different. There's a 2% chance of getting 500, which is 5 times the maximum you could get under option A. There's a 65% chance of 100, which is 10% less than the chance of getting 100 under option A. And there's a 33% chance of 0, which is an 8% greater chance of getting nothing than you get in option A. So in one way, we can calculate out expected values and we can assume people are going to act according to these expected values, but it's not that we're all human calculators and all we do is maximize expected value. So let's talk through a different example that'll help this, and then we'll talk through how people actually behave according to risk. Okay, so here's another example. So suppose you're presented with the following options you must choose between. So option A is status quo. What you have is what you keep. You don't get anything, but you don't risk losing anything. Option B, there's a 50% chance of gaining $110 and a 50% chance of losing $100. So it's sort of like if you woke up every morning and you chose option B, half of the time you're going to get $110 and half of the time you're going to owe $100. Now the expected value of option B is 0.5 times 110 plus 0.5 times negative 100. Well, this is 55 and this is negative 50, so the expected value here is a positive 5. If you were to have this option presented to you day after day after day, over a long period of time, option B is going to pay out more than option A, where you just keep what you have. That doesn't mean that you should prefer option B over option A. And in fact, a lot of times when this type of problem is presented to people, it's pretty consistent that they start preferring option A in a lot of cases. So what is it about people that is driving them towards option A, even though option B has a higher expected value? So everyone has different risk preferences. We refer to risk aversion as the propensity for most to prefer a less risky outcome when faced with two propositions with similar payoffs. So we can say that someone is risk neutral. So these are just different measures of risk aversion. They are risk neutral if they make decisions based on expected value only. So if you find yourself making choices based solely on what has the highest expected value, then you would be risk neutral. So for example, if you had one option that, there's a 0.01% probability, so tiny probability of gaining $1 billion, so a very small probability of a very large gain, and then the rest of that probability is 0. If you find yourself preferring that over all these different outcomes that have smaller payoffs but much larger probabilities simply because that one has the highest expected value, then you'd be risk neutral. You don't take into account that there's a very small probability that you're actually going to get that high thing. It's just mathematically that has the highest payoff. So it would this would be the example of, a human calculator. You just plug it into Excel or whatever, whichever is highest, that's what you choose. Someone's risk averse if they require a premium on any risky option, or alternatively, if they reject options with slightly larger positive expected values that have more risk. So these people are going to prefer things that are more certain, even if it means they have lower expected values. They would much rather, and this is, a lot of people are risk averse, and this is often why people take out insurance for different things. Homeowners insurance, car insurance, those sorts of things. They'd prefer an outcome that is slightly less risky, or that could be more than slightly less risky, but that is less risky even if it has a lower expected value. Now, there are also individuals out there that are what we would call risk loving, where they would pay for a risky choice, or they would opt for a choice with a lower expected value but more risk. So this is sort of like an adrenaline junkie, someone that just, they get some extra value out of the rush that comes along with taking on a risk. When we think of managers and corporations and firms, what we typically think of is we would like our firms to be risk neutral. We would like our firms to take on projects and make choices with the largest expected value and not take into account the risk. That's what most would argue. Now, you could make cases for others, but if we're incorporating all of the risks and all the benefits, and we're a firm, so we're assuming the firm doesn't have its own preferences, we would really like them to be risk neutral. However, we know that firms don't make decisions themselves. It's the CEOs and the executives and the managers and those people that are making the decisions. And those people, being human, they do have preferences. And some are risk averse and some are risk loving. What's interesting is oftentimes it's not the people themselves that are risk averse or risk loving, but it's how we set up our compensation systems. So if you offer very large bonuses, so the stereotypical, the hedge fund manager who gets this massive bonus, if they, get such and such a return, they're going to tend to be risk loving because they're incentivized to through their bonuses. One of the readings I'll post to Blackboard, though, talks about how CEOs, because a lot of their compensation is in stock ownership, and because stocks, they tend to kind of go with the market, they tend to make decisions that minimize risk. So they're too risk averse relative to what's best for the firm because of the way they're compensated. Now, one thing that decision makers can do is they can hedge. This isn't a investment class where you'd spend a lot of time talking about different hedging options. But from the perspective of a decision maker, you can hedge an investment, a decision, a choice that you're going to make to try and reduce the risk of adverse events. So oftentimes this is you could merge with another firm to try and diversify to hedge some risk. You can pursue different competing projects at the same time to hedge some risk. There's lots of examples we can use of how you can hedge risk, and I'll go through for a particular industry in a different video within this module. I'll go through an example of hedging in that particular industry. But anytime we talk about hedging, it's making a choice or an investment that reduces the risk of some adverse event. Now, how do we make decisions under risk? So expected value is going to come into play. Oftentimes, we sort of pursue three different avenues here. So we do sensitivity analysis, where we look at how sensitive are our results to maybe the probabilities that we're putting on different events or the payoffs that we're expecting. And then we sort of do sensitivity where, okay, what if we're off in terms of our assumptions on some of these probabilities slightly? How does that change our results? What if we're being overly optimistic on a payoff? How does that change our results? There's also scenario analysis where you look at different possible outcomes. And then there's decision tree analysis that oftentimes people are doing decision tree analysis without physically sitting down and writing out a decision tree, but it's useful to think of because it actually incorporates all of the above if done properly. So let's walk through an example of decision tree analysis and see how both scenario analysis and sensitivity analysis are built into this. Okay, so here's a very large decision tree. It looks like a extensive form game tree. So with the difference being that we only have one player in this game. We have the decision maker who's sort of right here. The decision maker is making all these decisions on a product. Okay, so the way we want to think about this is we've got a firm, we've got a CEO within a firm, whoever's making the decisions, and they're making some choices. Okay, so they can, with a new product, they could decide to drop the product. That's an option here. They could decide to test market the product to see how people respond to it, or they can just skip straight to a national launch. Okay, so let's make some assumptions here. Let's say that if they go through and they decide to test the market, there's some costs here. Okay, so it's costly. $3 million in costs if you go to test market. If you go straight to national launch, you can skip that $3 million in costs. And obviously, if you drop the product, you don't have any costs associated with that. Now, if we follow the tree along, so we're going from left to right, if I go and I test my product, which costs $3 million, My guess is there's a 60% chance that after doing the tests, that the feedback is good, that consumers are liking the good in question, in which case, after getting that feedback, I choose whether to go with a national launch or drop the product. There's a 40% chance, though, that people would perceive my product as poor quality, in which case I still have the same choice of national launch or drop product. But notice that if I go with national launch, my probability of having high sales, my probability of that launch being successful are much, much higher. Not guaranteed, because we're dealing with risk. They're much, much higher if I get good feedback. There's an 80% probability of getting high sales. Whereas with a national launch with bad feedback, there's only a 30% chance of getting high sales. Whereas the rest of the probability is attached to low sales. Okay, so let's sort of think through some payoffs here. So if I go with a national launch and I get high sales, I'm going to end up with, let's say that my payoff here is 20 million. And if I go with low sales, my payoff here is 10 million. Okay. And same thing down here. If I go through and I go with my test market and I end up with high sales, I get 20 million. And if I get low sales, I get the same 10 million. So my sales values are not dependent on whether I got good or bad feedback. It's just the likelihood of getting high sales or low sales is dependent on that. If I drop the product, I'm simply out the 3 million I spent. So this is -3 and this is -3. Simply out the 3 million that I spent in the test marketing. Now, if I go straight to a national launch and I get high sales, I get 23 million. Okay, why more than 20? Because by skipping the test phase, I'm getting to the market quicker and I'm gaining an advantage by reaching the market faster and being the first one into the market. So there's more profit available for me if I go with a national launch. If I end up with low sales, then I have -7 million. Okay, now what is one to do here? Now, if we incorporate what we've talked about in terms of expected value, we could calculate out the expected value of all these different choices and figure out what would happen. Okay, so for example, if I find myself right here, okay, so if I find myself right here, then what has happened is I have gone through and tested the market. I got positive feedback. If I go with a national launch, my expected value of the national launch is I'm going to get 20 million. So the expected value of this choice is 20 million times 0.8 plus 0.2 times -10 million minus the 3 million that I paid to test the good. So my expected value of this outcome is 11 million. Okay. Now, I'm going to compare this 11 million with this -3 million. And if so, I can determine. So this is basically backward induction. It's just we don't have a second decision maker. We're just sort of thinking through what I would do at different stages. So the firm would choose, because the expected value is much, much higher, they're going to choose to go with the national launch rather than dropping the product if they test market and get positive feedback. Okay, same thing down here. My expected value, if I have bad feedback and I go with a national launch, is I get 20 million, but now the likelihood of me getting that is only 0.3 plus 0.7 times -10 minus 3, because it cost me 3 million to test the product. And when I do that, I get -4. Okay, now here I've got a chance of -3 or -4. So if I get bad feedback, my best response, if I'm risk neutral, so if we're assuming the firm is risk neutral, is to drop the product. Okay, so now we know if we test market the good, so expected value of test marketing, the expected value 60% of the time I am going to get good feedback, in which case what we just figured is that I will go through with my national launch and I will get 11 million. So my value of test marketing the good is 60% of the time I get 11 million. And then 40% of the time I get bad feedback. And what we figured was if I get bad feedback, I'm going to drop the product. So this is times -3. So my expected value of going through with a test phase or testing the market is 5.4 million. Okay, no, that's greater than dropping the product, in which case I get nothing. So one would expect that they would prefer to test the product over dropping the product. The question is it more beneficial to test the project or go straight to a national launch? Okay, well, if they go with a national launch, then the expected value of that outcome is going to be they get 23 million and they get that 50% of the time, so times 0.5. Now, the reason they get 50% high and low, they haven't done the test phase, and so this is just their best estimates of what they think how they think the market's going to respond to their product. Okay, and then the other 50% of the time, so plus 0.5 times, they lose 7 million. Now, if you calculate that out, you get 8 million here. And so if we compare these two expected values, now again, how risk averse someone is, how risk loving someone is, whether someone's risk neutral, what we can say is this has the higher expected value. So in terms of a risk neutral firm, they should go straight to a national launch and they should skip doing a test market. Now, if someone is very, very risk averse, then they might not like the 50% chance that they could lose 7 million because they haven't done the test marketing, and they might prefer the 5.4 million. Even though it's a lower expected value, it might have less risk because I'm going to spend 3 million, sort of dip my toe in, see what the water's like, and if I get bad feedback, I'm just going to drop the product and be done. So if someone's really risk averse, they may very well expect or choose the test market version. But in terms of a risk neutral firm, they would prefer the national launch version. Now, in terms of scenario analysis, we've outlined all these scenarios. So one scenario is a test market, and then you could have good feedback and a national launch. So all these branches are really different scenarios. And you could have other scenarios too if you wanted. So maybe you get mediocre or average feedback instead of just good and bad. You can add in other scenarios. And then the sensitivity analysis would be go through and recalculate all these, but what if we assume that good is 0.7 and bad is 0.4 after I run my test? Okay, well, if that's the case, then our payoffs are going to change. And at some point, it might be for a risk neutral firm advantageous to do the test market if we change the sensitivities of some of these probabilities or initial payoffs. So this is one way of thinking through how a company can deal with risk and think through risk, but it's still the decision makers and the way they evaluate risk that's going to determine what choices are made. The expected values are telling you mathematically what to expect with risk and uncertainty, but it's up to the decision makers, and often, as I mentioned before, how we compensate those decision makers to determine what choices are actually made.